Video, we'll go through the answers to the chapters 1 to 2 multiple choice chapter test that we did. So let's get started. If we look at question 1 here, it says that the variables number of family members and age group are, and then it wants us to decide what type of variable they are. Number of family members, that is going to be a numerical variable for us. And numerical discrete because it's just our counting numbers and we can count how many people are in our family. Age group here, where it's got it broken up into the different subsets for us, these do create different categories for us, but because we can rank the ages, so 15 to 24 and then 25 to 34 is older and then 35 to 44 would be older again, this would be a categorical ordinal. So the answer here is going to be C, saying that it's a numerical variable and then an ordinal variable respectively. And that word respectively on the end there means in the order that they were listed in the question. So family members is numerical, age group is then ordinal. Questions 2 and 3 then relate to this example here, and it's got they've interviewed 7 drivers that have entered a supermarket car park, and then it's got 5 variables which are our bold headings of the table. So the variables are distance, sex, number of children, type of car, and then postcode. And to start with, it wants us to find the mean and the standard deviation of the variable distance. So I have put those distance values into list 1 for us, and for us to find the mean and the standard deviation, we want to go calc one variable and then just leave it as list 1. And if we now press OK, it tells me that the mean x bar up the top is 2.8. And for the standard deviation, I want to scroll my eyes down to where it says SX. And if I look across there, then it is 1.8. So again, here the answer for this one is going to be C, 2.8 and then 1.8. Now, question 3 is a little bit of a doozy. It makes us think, and it asks us about the number of categorical variables in the data set. So I'm going to go up to the top of the table here and just work through each variable. Distance there is going to be a numerical variable. And if we think about the question, I'm asking you, how far did you drive to the supermarket? So that's numerical. Sex there, female, male, is categorical, and again the question would be, what is your sex? Number of children, how many children do you have, is numerical. Then type of car, whilst there are numbers here, it actually has a key to tell you that number 1 means they own a sedan, number 2 a wagon, 3 other. So this here is actually a categorical variable because each number is representing a different type of car. And lastly, with postcode, again, thinking of the question, I'd ask you, what is your postcode? And for us, we might say 3810, which is Pakenham, or 3806, which is Berwick. This is actually a categorical variable as well, because all that number represents is a different location that you live. Finding the average of those numbers actually doesn't give me anything meaningful at all. So if I look across this, I've got 3 categorical variables that we've decided on. So the answer here is D, 3. And I guess my point that I just want to emphasize is think about the question you would ask in order to give that variable answer. And if you're asking questions that start with what, then that's indicating a categorical variable. But questions that start with how, and I mean typically how many, that then indicates that it's a numerical variable. Question 4 and 5 then relate to this histogram and box plot that's underneath it. So it says that the histogram and box plot shown both display the distribution of birth weight in grams of 200 babies, and the histogram here has percentage frequency as the scale, and then we've got that box plot below. Question 4 says the shape of distribution of the baby's birth weight is best described as. We actually answered this one really well. The answer is E here, that it is approximately symmetric with outliers. So we know these little dots on the end represent outlier data, and we can see that the size of the box and the whiskers do look pretty similar in the middle there. Question 5 unstuck us a little bit just from reading the question. It asks for the number of babies with a birth weight between 3,000 and 3,500 grams. So the best way for us to do this is to look at the histogram, and 3,000 to 3,500 is talking about this column here. If I take my ruler and pen and rule that across, it does end up looking like approximately 37%. And so it was a really common answer for people to select C, 37. But it's important to point out it says the number of babies. And at the start of the question, it tells us there's 200 babies. So if we want to now know how many babies, we need to work out what 37% of 200 is. And if we do that, it becomes 74 babies. So the answer for question 5 is D. Question 6 here, it talks about then an ordered set of data containing an odd number of values. The middle value is always blah. So if I've got 5 numbers, let's write 1, 2, 2, 3, 7. The middle value here we would know is our median, and so the answer is B. A few people said it is the mean and the median, but that wouldn't be true because any of these numbers could be an outlier that might really skew the mean. So we don't know for sure that it is the mean, but we do know that the middle number of an odd number of data is always the median. Question 7 here, it's got the histogram below shows the distribution of the number of billionaires per million people for 53 countries. And so using this histogram, the percentage of these 53 countries, so again that word percentage, with less than 2 billionaires per million people is closest to. If we look at this histogram, less than 2, it's talking about this first column here, and up here we can see that is 49 people. So it was common for people to select A, but again, highlighting in the question, it asks for the percentage of people. So we actually need to know 49 out of 53 times by 100. And sorry, if I open my calculator up for us, head back to the main menu, 49 over 53, we get 92.45%. So the answer here is D. Question 8 then builds on this, but what's happened is they've converted it to a log scale. So again, it shows that distribution of number of billionaires per million people. But we've got the log scale here, and the question says, based on the histogram, the number of countries, so not the percentage, just the number, with 1 or more billionaires per million is. So remember, with a log scale, we should write underneath what the numbers are straight away. I like to start at 1 because that tells me I add 1 0, so that's 10, 2 means 100. Just 0 is the number 1. So when I want 1 or more billionaires, I'm talking about this across. And we can see the frequency for this column is 9, and the frequency here is 1. And so I need to add them together, and my answer here would be E, 10. Questions 9 and 10 then link to this information at the start. It says the foot lengths of a sample of 2,400 women were approximately normally distributed with a mean of 23.8 centimetres and a standard deviation of 1.2 centimetres. The expected number of these women with foot lengths less than 21.4 centimetres is closest to. So to help us get started here, we need to draw that normal distribution curve. I'm going to label my mean in the middle, which was 23.8. Now, because it just wants less than 21.4, I do know that I have 3 standard deviations below and 3 standard deviations above. But since 21.4 is less than 23.8, I'm just going to worry about this smaller end. So this would here, I would subtract 1.2 from 23.8, which gives me 22.6. And this here gives me then 21.4. Now, less than 21.4 means out this way. And since 21.4 is our 2 standard deviations below the mean, remember 95% of the data fits in here, and 2.5% of the data then sits in each tail. So what we have is 2.5% of the women have foot lengths that are less than 21.4. But the question wanted us to answer this as a number. So if I want the number of women, I need to do 2.5 over 100 times by 2,400, because that's how many women were in the original study. And if I do that, then I get 60 women as my answer, and so the answer here is A. Finally, for question 10, it says that the standardized foot length of one of these women is Z equals negative 1.3, and it wants us to find her actual foot length. For us to do this, remember that the formula for an actual score is the mean plus the Z score multiplied by the standard deviation. So I just have to substitute in the information that I have from the question. So the mean was 23.8, and then plus negative 1.3 times that standard deviation of 1.2, and I can type this in my calculator exactly how it is written, and I end up with 22.24. So the answer is closest to A there, being 22.2. Okay. Question 11 here has got this table, and it says that the blood pressure low, normal and high, and the age under 50 or 50 years and over of 110 adults was recorded, and then it's displayed the information in the two-way frequency table. It wants to know the percentage of adults under 50 who have high blood pressure. So we want to look at this table of under 50, and then high blood pressure, it's 11. Common thing then, people said the answer A, but remember it wants the percentage. So we need to work out this 11 as a percentage of the people who are under 50 years. So we need to do 11 over 58 and then times that by 100 to find this percentage here. So if we type that in, we get 18.97%. And so it is closest to B, which is 19% for us. Question 12 gets us to look at a segmented bar chart, and it says passengers on a train were asked why they travelled by the train, and so then there's 5 different reasons, and they've been displayed here. It says the percentage of passengers who gave the reason no car is closest to. If we look at the key, no car is this grey colour, so it's this bit here, and what we should do is take a ruler and take these lines across to the scale on the side there. If you do that, you'll see that there is 8% that sits between 80 and the first line, and 6% that sits between 80 and the bottom line. And so if we add up 80 and 6, we get 14%. So the answer for this one here will be A. I'm going to stop there, and on the next video we will start from question 13 onwards.